This next problem, I filled in the parent function quickly because we know parent is at 0, 0. We know if we have 1, like y equals x squared, 1 squared is 1, 2 squared is 4, negative 2 times negative 2 or negative 2 squared is also 4, etc. So I drew in this so that we can see comparisons. So first thing, if I see this negative is negative 0.4, we know it's going to be upside down like we saw in the last video. Absolute value is 0.4. If the absolute value is less than 1, it's opposite of intuition. It should be wider than the parent. Okay, so let's just quickly make a table. I'm going to write x, y. I'm going to always have my vertex in the center, and we know for this, right, when it's y equals something x squared, your vertex is always 0, 0. I'm going to pick two values on either side. So I'll pick that, and I'll pick 1, 2. Okay, so for this first one, if we have y equals negative 0.4, I'm going to do negative 1. So if we have y equals negative 0.4, negative 0.4 x squared, and if I choose to plug in negative 1, don't forget to do order of operations. So negative 1 squared becomes positive 1, right? Negative 1 times negative 1 is 1. And then 1 times the value in front. We do that next. PEMDAS, right? Parentheses first. Negative 1 times negative 1. Negative 1 squared is 1. And negative 0.4 times 1 is negative 0.4. Down here, if I do the same thing, if I had y equals negative 0.4, and if we're plugging in 1 for x, we would get 1 times negative 0.4, which is still negative 0.4. Okay, so if we plug in 2, we're going to get two squared, which is 4, and 4 times negative 0.4 is going to get us negative 1.6. Now you can use your calculator if you would like. You should be able to do this all by hand, but you can check with your calculator, right, by plugging the equation in and then looking at the table. Okay, so I'm going to do the equidistant trick. If I know that 1 is 1 unit to the right, I know that negative 1 is also 1 unit to the left, so their y values are going to be the same. That's why we have negative 0.4 and negative 0.4. Then if I know similarly that negative 2 and 2 are 2 units away, their y values are going to be the same also. So I'm also going to have negative 1.6. And so if now we go and we graph this, I'm going to do this in, I'll do this in yellow. So at negative 1, it's 0.4, do dot there. At 1, it's also 0.4. At 2, it's negative 1.6. And at positive 2, it's also 1.6. And we're slowly creeping out. These values aren't exact, okay? And if I do that in yellow, we notice that my parabola, I should do arrows, is upside down because it's negative, and it's also wider than the blue, wider than the parent function. Okay, so if we go to the next one, and I make a table. You always want the vertex in the center of your table. Again, your vertex is not always 0, 0. It's just because all we have is something x squared, right? Y equals ax squared. If there's no bx and no c, you always know vertex is 0, 0. And we'll talk about how to find the vertex next lesson. So if we want to plug in two values on the left, two values on the right of your vertex, so let's plug in, let's say -1, and we'll do -2, and we'll do 1 and 2. Now, I'm going to plug in +1. So if I plug in +1, I would have 1 squared is 1, right? And -5 times 1 is -5. If I plug in 2 for x, we always use parentheses when we plug in. 2 times 2 is 4. 2 squared is 4. And 4 times -5 is going to get us -20. So we get -20. So again, doing our equidistance trick, if I know 1 is 1 unit to the right and -1 is 1 unit to the left, I know my y values are going to be the same. So that saves you a little time. You can plug in -1, right? -1 in parentheses squared is 1 times -5 is -5. Okay, if 2 is 2 units to the left, 2 units to the right, 2 and -2, we know the y values are the same, -20. So we have -1, -5, 1, -5, and -2, -20 is going to be like way down here and really narrow, okay? And then I'll do this in yellow. Vertex, come down. Vertex, come down. We should have some arrows on there. And we know it makes sense based off what we said. Negative, it's upside down, the yellow's upside down. Comparing to the parent's in blue. The yellow, the equation that we're looking at, j of x is equal to -5x squared. Absolute value of -5 is 5, which is greater than 1, so it is narrower. The yellow is narrower than the blue, than the parent function. Okay, so if we look at this next one, if we make a table, we'll put 0, 0 in the center. And I'm going to do these ordered pairs in my head, okay? Because at this point, you guys know how to plug in ordered pairs. So if we plug in 1 for x, 1 squared is 1, and 1 times 4 is 4. If I plug in 2, 2 squared is 4, and 4 times 4 is 16. Right? I'm squaring it, then multiplying by a number in front. If I plug in -1 for x, parentheses, -1 times -1 is 1, and 1 times 4 is 4. So we square, and then we multiply by a number in front, the coefficient. So -2 in parentheses, -2 squared is 4, -2 times -2, right? And then we multiply by a number in front, we get 16. And remember, you can do the equidistant trick. 1 unit away in both directions, the y values are the same, right? 2 units away from the center, the y values are the same. So we have -2, 16. When we weigh down here, no, that's not really drawn to scale. And 2, 16. Then we have -1, oops, I did that wrong, sorry. So let me erase that. And you know why I knew that that was wrong? Because I knew it should open upwards. So it's how you self-check. So -2, 16. Gonna be like way up here. 2, 16, gonna be way up here. No, -1, 4 is gonna be here. 1, 4 is there. Vertex there. So do some yellow. So, you know, and this makes sense. Our yellow, and we always put arrows, is positive, so it opens up. and absolute value of 4 is 4, which is greater than 1, so we know it should be narrower, and the yellow next narrower than the blue. Okay, so over here, if we look at this next one, we okay, so for this next one, we make our table. And we put our vertex in the center. We do -1 and -2. By the way, you don't have to do always -1 and -2 and 1, 2. Okay. And I'm just picking those because -1 and -2 are to the left of 0 on the number line, and 1 and 2 are to the right. We're just looking at those x values when we choose what we want to plug into the table so that we see the shape on both sides. If you just plug in random values, you may not see that parabolic shape, the U shape, right? Remember, you don't want straight lines. It's not absolute value. It's got this U shape to it. So if I plug in -1, -1 squared, -1 times -1 is 1, and then 1 times 0.8 is 0.8. If I plug in -2, so -2 squared, -2 times -2 is 4, and 4 times 0.8 is going to get us 3.2. Right? So if we plug in again, 0.8, how we got that, times -2 squared, sorry, it's hard to see, 0.8 times 4 gets you 3.2. So same thing over here, because it'd be equidistant. 1 is the same unit away from -1 from the vertex. We're going to get 0.8. And 2 is 2 away from the vertex, just like -2, so we're going to get 3.2. So if I go to graph this at -1, it's going to be like 0.8 at 1.8, and -2, we're going to have about 3.2. At 2, we'll have 3.2. At -3, we would have 7.2. Oops. There. And at 3, we would have 7.2. So the more ordered pairs, obviously, you plug in, the better your sketch is going to look. Oops. And we can see that this yellow compared to the blue, compared to the parent, notice I put arrows, is wider, and that makes sense, right? 0.8 is positive, so yellow should be pointing up. 0.8, absolute value of 0.8 is 0.8, which is less than 1. So smaller than 1 means it's going to be wider. Opposite of intuition.